Hi, good morning, everyone. Today, Dhruv, am going to talk about my project, Prompt Engineering for Lender and Applicant Sites at Parlay Finance. Small businesses are crucial for our economy, but they often struggle to get loans because of traditional lending processes, as they are very slow, expensive, and complex. Parlay Finance is solving this problem with its AI powered loan intelligence system which uses real time financial data and advanced AI models to make lending decisions faster and more accurate. LIS reduces manual work by 80% and increases loan approval rates, helping lenders process more applications while ensuring accuracy and compliance. This makes it easier for the small business owners to understand their loan eligibility and get matched with the right lenders, unlocking better access to financing. Now we will see the difference between LOS and LIS. Traditional loan origination systems, LOS, make loan decisions based on fixed rules and credit scores, giving a limited view of the borrower. Parlay Finance's loan intelligence system, LIS, takes a more advanced approach by capturing real time financial data from third party and proprietary sources to generate actionable insights for the lenders. While LOS focuses on static data for transaction processing and provides only retrospective insights on credit and portfolio risk, LIS offers a complete financial picture, enabling smarter decisions and better loan matching. This leads to faster and more accurate lending outcomes. The role of Team 3 is to generate accurate prompts, which gives clear and accurate summaries about the loan applications. The summaries are abiding the SBA regulations and the lender criteria. We are then testing the prompts to minimize bias and enhance the clarity. Now we will go through the system design of the LIS application. It starts with collection of raw data from various sources like Amazon S3, PostgreSQL databases, and external APIs like Vertical IQ, along with data from companies like MasterCard and others. This data includes the applicant's information and lender's credit requirements. A machine learning model then uses this data to determine if the applicant is eligible for different loan types based on the lender's criteria. The result of this evaluation is then summarized using Amazon Bedrock, an AI service which is used to create a profile summary of the applicant. This summary is displayed on both the lender's and the applicant's dashboard, providing insights and suggestions on how to improve the application further. Essentially, the system automates the loan eligibility process by analyzing data, applying machine learning, and summarizing the findings for easier understanding. Now we will go about the analysis. So, prompt is a text that tells us what an LLM model to do something useful. The process of creating effective prompts is called prompt engineering. This is an example of how a prompt works. Now we will talk about prompting techniques. Prompts can be created in two ways. First, few shot prompting. Few shot prompting is a powerful strategy for enhancing the performance of AI models, particularly in situations where extensive data training is scarce. Instead of relying solely on pre existing knowledge, the model is provided with a small set of curated examples, often just a handful, that demonstrate the desired input output relationship for a specific task. These examples serve as in context learning, guiding the model towards recognizing patterns and understanding the nuances of the task at hand. By observing these demonstrations, the model can adapt its internal representations and generate more accurate and relevant responses when presented with new, unseen inputs that are similar to the provided examples. Second is chain of thought prompting. This is a method that is designed to unlock the reasoning potential of large language models by guiding them to think through problems in a structured, step by step manner. Instead of just asking for a final answer, COT prompting encourages the model to articulate its thought process, essentially showing its work. This is achieved by crafting prompts that explicitly request the model to break down complex tasks into a sequence of smaller, more manageable steps, thereby mimicking human reasoning. By generating these chains of thought, the model not only arrives at a final answer, but also provides a transparent and traceable record of how it reached that conclusion. In the image, you can see an example of standard prompting versus chain of thought prompting. So, using Amazon AWS Bedrock, we were able to compare a number of models for choosing the best performance of the LLM. Among those models, Claude Sonnet 3.5 gave the best results and accuracy. To improve the results, we followed steps like structure responses, which provided clear examples and enhanced decision making clarity. Talking about the results, the original prompt provided was enhanced by the following mentioned steps. This slide shows the difference each prompt had than the previous one. Initially, in the first draft, we improved the clarity and structure of the original output. Then, in the second version, we further increased the explainability of the output and provided a detailed breakdown and stronger justifications. Now, we have submitted the prompt to the banks who will review the prompt and let us know if they are satisfied with the output. The analysis highlights three key findings. The model maintained consistency, clarity, and interpretability in its own responses across different iterations, indicating a stable and reliable performance. Furthermore, no biases or sensitivity concerns were observed, suggesting that the model is fair and unbiased in its outputs. However, the analysis also notes a limitation, which is the edge cases or future analysis was not performed due to limited data availability. This implies that while the model performs well in general, its behavior is unusual or challenging in scenarios, and that remains untested, potentially highlighting a need for more diverse data in future evaluations. Here we are tracking the current status and we are waiting for the banks to let us know whether they are satisfied with the current prompt or and based on the suggestions that they provide us, we will be making tweaks on the existing prompts so that we are able to uh, complete the requirement that they have presented to us. These are the team members for the team three, which are working on the prompt engineering problem for Parlay Finance. And thank you for going through the presentation.